Okay, so this video is solving exponential equations with different bases. So I will just say that these equations can get pretty involved, and I want to start off with more basic or more elementary problems, but or the ones that are really good actually that we might actually use sometimes. So let's just look at this one, 2 to the x equals 7. Okay, now the thing about this problem is that I cannot use my times table to write 7 as a power of 2. So let's just, over here, here's an easy problem, I think. 2 to the x equals 8, and I write 2 to the x equals 2 to the third, so x equals 3. That's an easy problem. I can use my times tables to know that 8 is 2 times 2 times 2. We don't have that situation here. So what we do is we follow these steps. Step 1, which is isolate the exponent, which we've already done. So, I mean, we didn't do it. It was already done for us. It was already there. Step 2, apply ln to both sides. And that is, well, you don't have to do that. I mean, I'm going to tell you actually you have to do it when I do a test, when we have a test. But what we could do is we could write this as a logarithm base 2, and that would give us an answer. But in general, it's good to express things in terms of natural log. You could use common log, but natural log is sort of the one that math and science people want to do. So what I do is I put ln on both sides. Okay, so ln's a function. When I apply it to both sides, these two are equal to each other. And then what I do is I bring the x in front. All right, now what I have is a number. ln2 is a number. We could look it up on the calculator and get an approximation. However, using a calculator will only give us an approximation. It's an irrational number, and so anything on the calculator will just be an approximation. And so what I'm going to do then is I take this and I divide both sides by the same number, and then I cancel. So x is equal to ln 7 divided by ln 2. Don't do anything with that. It does not simplify to anything else. There's no, there's just nothing that can be done with that. There's no property of logarithm that will do anything with this. All right, so that's one problem that we just did. That's A. Let's try something where I have base E. Okay, the truth is that many, if not all, or most scientific equations, when they have exponents, are using base E. It's just the go-to one that people use, and there's reasons for that, which we'll discover when we take calculus. Okay, so first I'm going to, the thing is I did step 2. I didn't write step 3 here, so I should write step 3. Well, step 3 would bring the x out in front. Step 4, solve for x. Okay, let's just do this. Step 1 is isolate the exponents. So one of the things we do not want to do is we do not want to apply ln to both sides here while the 3 is there. That will not be what we want to do. And when I say isolate the exponents, that just means divide by 3. So I have an exponent equals a number. And then step 2, apply ln. So I have ln e to the 2x equals 7/3. Okay, now what happens here is that logarithm and exponent cancel each other out. And that is why we like to use base e, especially if we're going to use the natural log, is because of that cancellation property. And now I can divide both sides by 2 or multiply by a half. So I finally get x is equal to 7/6. But we're using in a very big way here that ln and e cancel out. You can also use, here's ln e to the 2x equals 7/3. You could bring the 2x in front and just use the fact that ln e is equal to 1. So I sort of don't like to do two different ways because you don't know which one to follow, but I think this is the best way on the right hand side. Okay, let's try another one. It seems like we should do 3 for some reason. Okay, this one here is, I think, just going to be maybe too much. Let's do 2 to the x equals 3 to the x plus 1. Now, the thing is that we'll really see why not having base e is just a lot of trouble. Okay, what we can do is we can bring these exponents to the front. And it's totally doable. Especially if you didn't have the ln here, then you would say, oh yeah, of course I can do that. That was from my beginning algebra class. But somehow if I have this ln, it gives people a little bit of, I don't know, just a little bit of something that makes it confusing. What I'm going to do is I'm going to subtract to bring all the x's on one side. And then I have a number on the other side. Then I'm going to take out the x. And then I solve. Okay, that's all.